Hello again, Year Sevens. We've got another Flashback Friday for you. We're flashing back all the way to really early in Term 1. All right, so we're almost back at the start of the year now when we were learning whole numbers. And the topic from whole numbers that we've picked out that we think is really, really important for you guys moving forwards is factors, prime numbers, but mainly factors. Because factors are really useful when it comes time to do some algebra and stuff like that. It's really helpful when you're doing fractions or ratios or other stuff. Understanding factors is just really helpful in terms of just working with numbers in different ways, whether you know what the numbers are or not. So, what is a factor? A factor is kind of a small part of something. It's a building block of a bigger number. You should view a factor as something small that goes into something bigger than itself, but it does it evenly. You know, like a brick is a factor of a house. You know, a cell is a factor, of a human. You know, if you're making something out of Lego, you can view the Lego blocks as the factors of, the house or the car or, the fire truck that you make. So when we talk about factors, we're just talking about things that are small that go into something bigger, but they have to do it evenly. They help us construct numbers in different ways. So if I'm trying to make the number 12 with even groups, we know we can make the number 12 in different ways. We can go 1 times 12, one row of 12. We could also go 2 rows of 6, right? If I've got rows of 6, then I've got even rows, right? And I have 2 of them, and that's 12. Same for 3 rows of 4. And then I've also got kind of these things, but transposed, but flipped around the other way, right? So 4 rows of 3, 6 rows of 2, and 12 rows of 1, right? These are all the different ways I can use even groups to make the number 12, and making even groups shows me the factors. Okay, so the factors of 12 would be 1, right? Because it goes in evenly. 12, 2, 6, 3, and 4. And I don't need to write them down again, right? This is just me flipping, this one around, right? They're the same thing, just rotated. But 1 and 12 are a pair, 2 and 6 are a pair, and 3 and 4 are a pair. They times together to make 12, so they are factors of 12. All right, so we're going to be answering questions around these ideas today. So what we'll do with today's video, we'll just go through each of the questions that you'll be asked on your worksheet and just give you an example of how you can go about solving it. So that way you might be able to get through most of it without too much help. But if you get stuck on a particular question, you can just come and just find the right part of the video and just get an example of how it's done. So question 1, pretty straightforward. Is the first number a factor of the second? So we're just checking whether this number goes into that one, and if you look at the last slide, you know it does, but there's a few ways you can do it. You're allowed to use a calculator to check things today if you really, really want to. So we're really just checking whether 3 can times into 12, right? Because factors always multiply to make bigger numbers. So to work backwards and check that, you could just go 12 divided by 3 and see what that equals. If it does go in evenly, you'll get a whole number, right? Not a decimal number or a fraction, so that works. Another thing you could do is you could count by threes. And I do manage to get the number there, right? Or if you know your times tables, you'll just see whether this number goes into that number, whether this number goes into that number. So we went 12 divided by 3. We got a whole number answer. Tick. We also counted by threes. We got 12. Big tick. So that means this is true. It is true that 3 is a factor of 12. And you'll be able to finish that question by doing more of the same. Question 2. You have to find all possible factors of the following numbers. So we want to try and find as many as we can. Don't just mark yourself wrong if you miss one. Just try and find as many as you can. And if you miss one, oh well. But I would always start by putting in the number 1, because the number 1 goes into everything. And I'd also start by putting the actual number in as well, because 18 goes into 18 evenly, right? 1 and 18 are a pair. And for the most part, you should be just thinking about pairs of numbers, right? Because I might know that 9 goes into 18, which it does. And then I think about what number goes with 9, and I know that 2 lots of 9 makes 18. All right. Then we could also break down the number 9, right? Because if it goes into 9, it's going to go into 18. So I know that a number that goes into 9 is 3. And the number that pairs up with 3 times something is 18. Well, that's 6. All right, so there's a few different ways you can approach it. You might just know your times tables and know what numbers go in. But if you get stuck, start with 1 and the number itself. Try and find another number goes in. And then you might even be able to break that number down. Like if I had the 6 sitting there, I know that 2 times 3 is 6. So there's lots of ways of breaking it down and breaking it down. All right, but we want to try and list as many as we can, and don't beat yourself up if you just miss 1 or 2 out of the 6 numbers. All right, just try and get as many as you can. All right, question 3 shouldn't pose too many problems for you guys. We just got to find the number that goes in here to make the number at the end. 3 times something is 12. It is just worth knowing as you're doing this, so this is actually algebra, right? We have an unknown here we're trying to fill in, right? So when we get to next term and we all of a sudden put the letter X in your work, right, it looks something like this. It's just a missing number question, just like this is, right? You guys are okay with this. You've been doing it since primary school. When we put the letter X into it, Year 7s tend to get a bit grumpy with us. But this is the concept, right? What number makes this sum work? We know that 4 works today. So just be aware that while you're doing this, you're actually doing algebra and you're getting yourself warmed up for next term, because next term is going to be algebra all the time. All right, but all you've got to do here, think about what number makes the sum add up, and you'll be right. All right, with question 4, I'm not going to give you any of the answers because that'll just defeat the purpose of this question. But I have actually said the answer to question A earlier in the video, so if you remember that, well done. For B, you'll have to write 3 numbers that are bigger than 4 that have only 2 factors, right? So you're looking for numbers where nothing else goes into them except themselves and the number 1, right? Because 1 always goes in, and the number itself always goes into it as well. Right, I spoiled A again, and a prime number has only so many factors. If you don't know that answer, you better look it up. Question 5. Question 5 is a bit spicy for some people. What we've got to do with question 5 is use a factor tree to factorize the following numbers. That means we're breaking these numbers down into their smallest possible parts. We're actually breaking them down into prime numbers. So you probably don't remember doing this in term 1, but you did. So I'm going to show you an example. I might just choose B so you can do the other ones. So what you should be doing, you should be starting by writing the number itself down. And you should be choosing a pair of numbers. And you can choose any pair of numbers you want that goes into 30, as long as, when you times them together, they make 30. All right, so I might even do it a couple of different ways to show how you get the same answer, no matter how you start. So I might be looking at 30, and I might be thinking, I know my times tables. 5 times 6 goes into 30. All right, so we're breaking down the number 30 using it. It's called a factor tree, right? It looks like a tree. And we're looking for numbers that are prime numbers that I can't break down anymore. Right, so the number 5, nothing else goes into that. So it's good form to put a circle around it to show that we're going to stop right there. But the number 6 does have factors, apart from 1 and apart from itself. The number 6 can be broken down into a 3 and into a 2. All right, so these are prime numbers because 3 can't be broken down any further and 2 can't be broken down any further. So this is the prime composition of the number 30, right? Because every number is unique. Every number has its own combination of prime numbers. So the building blocks of a 30 are 2, 3, and 5, right? 2 times 3 times 5 makes 30, and you can't break down these numbers anymore, right? So that's a factor tree. Now let's say that you didn't start with 5 and 6. Let's say you found 10 and 3. Right? People often look at 30 and think, 10 goes into 30. That's fair enough. So 10 and 3 makes 30. In this case, this is the one I'd be circling because I cannot break down the number 3. But then I'd be thinking about the number 10. And I know that 10 can be made with a 5 and with a 2. All right, and again, I'm at the spot where 5 can't be decomposed or pulled apart. Neither can 2. So I've got the same combination of numbers again. I just went about it in a different order, 3, 5, and 2. All right, so I think for the most part, you will be mainly breaking things down into 2s, 3s, and 5s. But prime numbers are your go, right? So if you get to a 2 or a 3, a 5, a 7, an 11, a 13, these are numbers that can't be broken down any further. So you'd circle them and you'd stop with that part of your tree and you'd try and break down the other numbers until you can't break it down anymore. All right, those are factor trees. The second page of your worksheet takes it a step further. We're now going to be comparing 2 different numbers to look for things they have in common. Really important skill because it helps with things like fractions and ratios when you need to simplify it down. Because if you know what number goes into both, that's really helpful stuff. So what you'll be doing here, you'll be finding factors of each number and underlining common factors, right? So if I'm working with 4 and 6, we're doing what we did before, we're listing all the factors we can find. So the numbers that go into 4 are 1, 2, and 4. And the numbers that go into 6, 1 and 6, that's always a good place to start. And then also 2 and 3 make a 6. And then we just want to underline what they have in common, right? So we'll always be underlining the number 1. And then the only other number that goes into 4 and 6 is the number 2, right? We're just underlining things that go evenly into both, right? So that's question 1. We'll skip now to question 4 because 2 and 3 are pretty similar to question 1. If you get stuck at the end of question 3, this question will help you answer that if you watch it. So again, we're doing the same thing. We're finding all the factors of the two numbers, right? So with 1, 2, 5, and 10, we've finished the top line. Now 60 has lots of factors. So I might just fill it out down here, just because I know I'm going to run out of room. So I know that 1, 2, 3, 4, and 5 all go into 60, no problems. 6 does as well. And then I think we can start to find the numbers that go with these. So 6 times 10 is 60, 5 times 12 is 60, 4 times 15 is 60, 3 times 20 is 60. You guys are lucky I'm doing this one for you. Hopefully they haven't picked any other numbers that have this many factors. 2 times 30 and 1 times 60, right? The number itself should always be there, right? So 60 has 1, 2, 3, 4, 5, 6. It has about 12 factors that go into it. Again, we need to underline the common factors, right? So they both have the number 1 because everything does. They're both even numbers, so they both have a 2. They both have the number 5. And they both have the number 10. All right, so the purpose of this question is to find the highest common factor. Common means it's in both, and highest means biggest. All right, so you're just looking at all the numbers that you underlined, which one is the biggest, and you guys know that the number 10 is bigger than the number 5 or the number 2, the number 1. All right, so we're following this process of finding all the factors, underlining things that are in them both, and then you're just looking for the biggest one, right? So that means if I had a fraction with a 10 and a 60 in it, I'd be dividing both parts by 10 because it's the biggest number that goes into it. But follow this process to find the highest common factor, you'll be right. Okay, so that's going to get you through sheet number 2. Plenty of factor work to keep you busy today. If you get stuck, just rewatch the part of the video that'll help you out. And of course, we're always around to answer questions if you've got them. So good luck and enjoy your weekend.